In this video, we're working through the extra notes page for lesson 1.4 on the day 2 notes on elimination and matrices. In the first 3 examples, we're going to solve the system of linear equations by elimination. In example 1, if we're going to use elimination, remember the goal is to eliminate or get rid of one of our variables, x or y. And so we're looking for the coefficients in front of x or y to be opposites. So for example, 2 in front of this y and negative 2 in front of the other y, those are opposites. So if I were to add these equations together, my y's will cancel because they will add to 0. So when I do elimination and I notice that I have those opposite coefficients, I'm ready to add my 2 equations. And I'm going to add up and down. 3x plus 3x is 6x. 2y plus negative 2y, that cancels, that eliminates the y's. And 4 plus negative 4 is 0. And so now I've eliminated the y's, which leaves me with an equation with just x. So I can solve this for x. I'm going to go ahead and divide both sides by 6. And I see that x is equal to 0. Now I'm not done. I still need my y value. Remember, when we solve our system, we need the values of both variables. So I have x. I now need y. So I can take my x value and plug it back in to one of my equations above and then solve for y. So when I plug 0 in for x, I get 3 times 0 plus 2y equals 4. 3 times 0 is 0, so I'm just left with 2y on the left equals 4. Divide both sides by 2, and I get that y is equal to 2. In example 2, we're going to solve by elimination. I notice, however, that when I'm looking at the coefficients in front of my variables, I can't just add right away. If I were to add, neither the x's or y's will cancel. So I want to ask myself, is there anything I can multiply these equations by to make it so that I have opposite coefficients? I notice that I could take my top equation and multiply it by 2. Notice that will make this coefficient become positive 6. And so that way, when I add, I'll have a positive 6 and a negative 6. So the y's will cancel. So I'm going to go ahead and do this. I'm going to multiply everything in this equation by 2. So negative 10x times 2 is negative 20x. 3y times 2 is 6y. And 1 times 2 is 2. So I'm just rewriting that top equation, and I'll go ahead and write equation 2 underneath. Now I'm ready to add my equations. When I do that, my y's cancel, and I'm left with negative 25x equals 25. I'm going to go ahead and solve for x by dividing by negative 25. That leaves me with x equal to negative 1. So now I'm ready to find y now. So I can go back and I can plug 1 in for y into one of my equations. So negative 10x plus, oops, I'm sorry. I meant to plug that in for x. I don't know why I drew that to y. I'm going to plug it in for x. So negative 10 times negative 1 plus 3y equals 1. Negative 10 times negative 1 is positive 10. I'm going to subtract 10 on both sides. I'm going to divide both sides by 3. Get y equals negative 3. Okay. My last example on this page, example 3, I'm going to have to come up with a system of equations that represents the situation. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? In the last lesson 1.4 day 1, we mentioned that to define the variables, we want to know what is it asking us. It's asking us to find the cost of each type of van. It wants to know the cost of a small van and the cost of a large van. So those will be our variables. I will let L be the cost of a large van, and I'll let S be the cost of a small van. You can tell I'm going to get my equations from location A and location B. So equation 1, they had 5 large vans. So the total cost of their large vans will be 5L, 5 times the cost of each large van. Plus, they have 2 small vans, so 2S will be the cost of their small vans, and that equaled $235,000. For location B, the cost of their large vans will be 2L, and their small vans will be 3S, for a total of $160,000. I'm going to solve using elimination. I'm noticing that I do not have opposite coefficients. So what I can do is I can get the S's to cancel, or I'm sorry, the L's to cancel. And I'll times the top equation by -2 to get a coefficient of -10. And then I can times the bottom equation by +5 to get a coefficient of +10. Okay, and that will make the L's cancel when I go ahead and add my equations. So I'm going to multiply these, by -2 and 5. Okay, so I have -10L, 2S times -2, -4S. And then I have 235,000 times -2 is -470,000. Now I'm going to multiply my bottom equation. 2L times 5 is 10L. 3S times 5 is 15S. And 160,000 times 5 is 800,000. Ready to add my equations. That makes my L's cancel. And I'm left with 11S equals $330,000. I'll divide both sides by 11. So the cost of a small van is $30,000. Now I need the cost of a large van. So I need to take my $30,000 and plug it back in for S into one of my equations. Okay. So I'll do it to this equation 2. 3 times 30,000 is 90,000. I'm going to subtract 90,000 on both sides. Oops. Then divide both sides by 2. When I do that, I get that a large van costs $35,000.